Okay, this is part two of a Bayes risk presentation. So I just actually going back to where I started in the first one. Okay, what we want to do is calculate the what we've done is actually carried out the Bayes test, and what we're doing here now is calculating the associated Bayes risk. So what we want to do is actually use our cost values. So we have cost values here, okay, and the probabilities. Now we were given the cost values, and in the case of C00 and C11, it's 0. So essentially we can disregard this part and disregard that part. We know cost 10 and cost 01. So what we have to do is calculate the probability of 10, which is the probability of H0 given D0 given H0. Given I'll show you when I get there actually. So essentially what we have to do is calculate these joint probabilities here. And so we're going to use the conditional probability formulas to calculate them. Okay. So here we go. So in the last one we calculated the decision regions. Okay, R0 and R1. Okay. So what we want to do is compute the probability of D1 given H0, okay, which is in other words P10, and also probability of D0 given H1, okay. So what we are going to do here is calculate the conditional probability of the conditional probability using the conditional PDFs that we calculated earlier on. Okay, so essentially what we do is we integrate within the region minus 0.693 to 0.693. Just actually as an afterthought, what I decided to do actually is just actually, that's minus there. I got the minus and plus the wrong way around. There we go. R1 and R0. So essentially what we want to do is calculate the probability of D1 given H0 and D0 given H1. And essentially what we do is integrate these conditional probabilities in the R1 region. Okay, so this is what we're in particular we're looking at. Okay, so for this one, for PD1 given H0 within the R1 region. Okay, so essentially it is e to the integral of a half of e to the minus absolute value of x. Okay, now this is where knowledge of how to integrate absolute value functions comes in useful. This is equal to this this expression here is equal to this. Okay, 2 times the integral of 1/2 of e to the minus x from 0 to 0.693. Okay, now I did a separate video on this. It's going from this step to this step should be straightforward once you actually just sort of understand the rationale behind it. Okay, so anyway, this actually evaluates the half of the two cancel out, so we actually have e to the minus x. So essentially what we have to do is calculate e to the evaluate this definite integral. E to the minus x is minus e to the minus x, evaluated from 0 to 0.963, and when you do that you get a probability of 0.5. Okay, so what we are going to do now, that's the probability of D1 given H0. Okay, now we're just going to come back to that in a while. We're going to calculate the probability of D0 given H1. Okay, now we are calculating this in this interval here, so this region here, okay, plus this region here. Okay, so that is what we're looking at here. So from minus infinity to minus 0.693 to plus 0.693 to x. Now also what I've done here is I actually just like chopped out the because the absolute value functions are necessary when you're dealing in the negative region only. So essentially what I could do here is rewrite that as e to the 2x, and I can rewrite that as e to the minus 2x. Okay, so the even by that by the same token, what should happen is that they are sort of symmetrical of each other. So essentially I can double up 2 times that, okay, from 0.693 to infinity, okay, of e to the 2x dx. Calculate that out, I should get 0.25, right? So essentially what I'm able to do now is put all of the Bayes risk, all these calculations together, okay? So P10, as I actually sort of had it on that little grid earlier on, is actually, if you specify fully, it's PD1 given H0 times probability of H0, okay? Just as a remark, the cost is 1, so just actually 1 times that, okay? The cost is 1. The other costs are 0, that's why we dropped them. And the probability of P01 is probability PD0 given H1 times the probability H1, 2 times that. So the 0.5 times 2/3, we were told that in the question at the start, plus 2 times 0.25 times 1/3. Calculate that out, and you would get a Bayes risk of 0.5. Okay. So that is, let's actually just, that is everything we need. I actually have some workings here. I'll just actually pause it, just have a quick look at them there. Yeah, so what I've done there is actually the workings from earlier on where I calculated 0.5. I just went into it more detail here. So if you want to take a screenshot or something and just read through it and see if you get 0.5. Likewise for P, the other calculation there, this is how I got 0.25. Okay, I won't talk through it. It's if you're doing decision theory, you should be fairly okay with definite integrals. But just in case you want to double check or you want to query something, you can have a quick look at that. Okay, we'll leave it there.